Hello everybody. In the previous lesson, we talked about creating a little loop here, and some of us ended up with infinite loops on accident. That's okay. What we are going to be doing today is trying to actually tell what our hand is measuring. The way we're going to do that is by counting pairs. Let's try this out. So I'm going to throw a little function in here. Well, actually, this isn't going to be a function. This is going to be a subroutine. So I'm going to say private sub pair counter. Pair counter. Okay. And then what this is going to do is give us the number of pairs that we've found. So let's do this. Let's say dim pairs as integer. All right, and we'll just keep that up there for now. All right, so what we'll do when we run pair counter is we are going to count how many times the cards are the same number. So over here, we have a code that tells if the number is the same. If n mod 13 is 1, or if n mod 13 is 1, then those two numbers must be the same. So what I'm going to do is I'm going to take advantage of that. I'm going to say if card 1 mod 13 is equal to card 2 mod 13, then that tells me that they must have the same number on the card. We do need to check the other cards too, so let's do that as well. So this checks card 1 and card 2. I now also want to check card 2 and card 3, card 3 and card 4, card 4 and card 5, card 1 and card 3, card 1 and card 4. It's all these same ones over here. So let's actually take advantage of that. Let's go through here. Let's take this line. No, because that's just going to do it once. All right, we want to do it again every time one of the cards is the same. This might not be the most efficient way for us to do this, but let's go for it. I'm going to say else if card 1. Ooh, no, we don't want else if. We want this to happen every time. Every time one of them is the same, we want to stop and count. So we're going to say in here, pairs equals pairs plus 1. I do know that when I run this, this is not going to work. And it's going to probably break, and I want us to deal with that when we get there. So just know, when it doesn't work eventually, that was on purpose. I promise. I knew. Okay, so let's also say if, actually, let's just steal this code again. If card 1 and card 3 are the same, then we want to add 1 to the pairs. And then we're going to do this over and over and over and over and over again. This is going to be card 1 and card 4. This is one of those great lessons to just throw on headphones and just chug your way through it. So that's all the card 1s. Let's do a card 2 now. So card 2 and card 3. I'm going to recopy this. Card 2 and card 4. Card 2 and card 5. Okay, we're going to do this again with just 4 and 5. It's going to be card 3 and card 3. And then one more, just this one, for card 4. I'm going to slowly pan through this. Feel free to pause it and write this out. So let's go here, and let's go to the second half. There you go. You can pause it and go through. So this should count every time that there is a pair. And then I want to, for now, let's just report what that is. Let's say we'll go message box dot show I love to use message boxes for my testing. Whatever the number of pairs is, dot toString. Okay, this is just testing this. All right, so let's run it. And remember, I knew there was going to be an issue. All right, it says 1, good. It counted 1 pair, awesome. What if I do it again, though? Okay, we've got another pair. Wait, why does it say 2, though? Okay, let's hit it again. Okay, we've got 2 pairs this time. Why is that 4? What is it doing here? Let's do one more. This one, there aren't any pairs at all, and it still says 4. Well, the issue is we're not actually resetting pairs in between. It keeps adding to the pairs, see? So what I want to do here in the beginning is say pairs equals 0. We're going to reset pairs to 0 right at the beginning of this. And so now it should always count the correct amount of pairs. Let's test it. Hit it. If I look through this, I got no pairs and it says 0. Great. I hit this again, no pairs, says 0. Hit this, looks like there's 1 pair, it's a pair of 6s, and I got 1. Here I've got 2 10s, that's a pair. Here I've got 2 3s, got a pair. 1 pair again, 1 pair again, no pairs, no 1 pair, no pairs. I am going for something right now, hold on. Eventually it'll get there. Statistically it has to, right? Right? I should speed this up, but I don't know how. I'm not a video creator. Maybe I should learn how to do that. Especially since, you know, this part's taking forever. Oh my goodness. Just give me 3 of a kind, please. 3 of a kind. 3 of a kind. 3 of a kind. I want 3 of a kind. Where's my 3 of a kind? 3 of a kind. 3 of a kind. 3 of a kind. Okay, you know what? We're going to force this to happen. We're going to cheat. Instead of letting us come up with random numbers, we're going to literally say that, hey, card 1. I'm going to put a note here, by the way. I'm going to say this is cheating. And we'll get rid of that in a second. All right, card 1 actually equals 1, which is ace, right? And card 2 actually equals 14, which is the other ace. And card 3 actually equals, not, what is it? 27. Okay, that's going to give me 3 aces. Let's see what happens when I get these 3 aces. This is us cheating. All right, deal. Look, 3 aces. Oh, and of course I get the 4th ace, but it's counting 6 on here, so I should have 4 of a kind, but it says 6. Hold on, let me retry this again. Okay, so it's got 3 aces, and it says 3 there. Okay, that's kind of what we'd expect. Now there's 4 again, and it's counting 6. I wonder why that is. And the reason why is it's counting them like this. 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs, 6 pairs. Okay, so we got to keep that in mind. We can actually use that to our advantage. We're going to cheat like this quite a bit. All right, so let's, while we're doing the testing here. What time are we at? Oh yeah, we're good. We'll probably finish this project in this video. There's that, and I'm just going to give this another number. Card 5 equals, what is it? 3. Okay, so this should give me just the 3 of a kind. Ooh, my computer's not making happy sounds. There we go. 3 of a kind. Hey, that's 3. Okay, do it again. 3. Good. So if it's 3, then that's 3 of a kind. So at the end of pair counter, let's actually do something with that. Let's say if pairs is equal to 0, well, that's when it's just a high card. Okay, so we're going to say, what is this called? I don't remember what I called it. It was so long ago. LBL display. So LBL display dot text equals the word hand :space, and then we're going to concatenate that, meaning add or slap the word on the end of it. Oh, you know what? I'll just say this. High card. Okay, cool. Else if if pairs is equal to 1, well, let's see what happens when we've got a pair. So that's this, and we'll make this a 4. Okay, so this should be just one single pair. How many does it say there is? 1. Okay, it says 1. So if there's 1, then this should say pair. Okay. The next one was 2 pair. Okay, so let's make 2 pair happen. So 1 and 14, then we'll do 2 and 15. It should be 2 aces and 2 twos. Boop. 2 aces, 2 twos, and it says 2. So 2 of a kind, or sorry, 2 pair gives me 2. So we'll say else if pairs, not pairs, pairs equals 2, then this should say 2 pair. Okay, next is 3 of a kind. Let's make 3 of a kind happen. 3 of a kind is when we've got 3 of the same kind, which is 3, let's try 3 aces. If I get 3 aces, that says 3. Okay, so 3 is 3 of a kind. Easy peasy. Okay, we'll say if this is 3, then this should say 3 of a kind. Okay. Oops. Well, I guess let's test to see if it works. Hey, it says 3 of a kind right there. Beautiful. All right, next we want to know what a full house is. So full house is when you've got 3 of a kind and then 2 that are the same. So this should be 3 aces and 2 twos. Okay, 3 aces, 2 twos, and it says 4. So that's 1 pair, 2 pair, 3 pair, 4 pair. All right, so that's 4. All right, we're going to say if this is 4, then we want it to say full house. All right, and the last one that we are going to do as a class is 4 of a kind. And we already kind of talked a bit about this, but 4 of a kind is going to give me 4 aces, and that says 6, which is not exactly what we expected, but not that far off. So this is going to be 6, and this is going to be 4 of a kind. All right, so with all of our cheating, we've got everything figured out. This takes care of these 6 different hands. It's going to be kind of up to you to figure out straight flush, and royal flush. It's not a part of this project, but if you would like to earn a little bit of extra credit, go for it. I'll give you some extra credit if you do, I promise. So go for this. Let's test this to make sure it works. Let's get rid of the cheating. And I'm going to just go ahead and tell you, most of the time, the hand is just high card. That's why it's the lowest card. Oh, hey, there's a pair. Oh, let's get rid of that. I don't need this testing info anymore. Okay, run. There's a pair. The pair is 9s, okay? Pair is aces. Pair is 10s. Okay, a lot of pairs in a row. Okay, this one's high card. Pair is the aces. Awesome. Pair, it's that. All right, let's keep going until it's something else. Pair. Oh, I saw 2 pair and we went right past. There's 2 pair. 2 queens and 2 9s. Awesome. All right, so this should go up until actually let's have a little fun with this. I'm going to, you can end the video now and just be done. I'm going to do something a little bit fun. I'm going to add in a timer, and then whenever that timer ticks, I'm going to re-deal. So yeah, here we go. We'll say go to deal. I wonder if it'll let me do that. Nope, it won't. Okay, whatever. So I guess that's only within the same function. It's fine. It's fine. It's fine. Okay, so what I want to do then is, man, okay, whatever. We'll just take this and we'll put it into here. Okay, so now it's in both places, just for fun. So whenever this ticks, it'll run this again, and I want this to, let's say, have it stop when, so timer 1. So if it's, we'll say full house. So if it's a full house, we'll say timer 1 dot stop. Okay, let's try that. And let's get this timer actually running. Properties, let's make it enabled, and let's make it happen really, really fast. Let's go every 20 milliseconds. All right, and we will run it. And eventually, it should, oh, there we go, full house. So 3, 3, 3, 2, 2. Great. So that happened pretty quick. What about if we want to do it for 4 of a kind? 4 of a kind is the most rare one, so let's go with that. Drag it into here. Wonder how long it'll take to do. I mean, it could be right away, technically. All right. We'll keep it going and keep it going, and this is doing a lot to my computer. It's taxing it a little bit, but well, it's not taxing it that much. Looking at the CPU uptime, it's what percent? Like 9%. Yeah, that's nothing. We're good. I am looking at this. This is something called garbage collection. Oh, there we go. 4 of a kind. It took us a while. Actually, we can try and figure this out. How long did it take? It took us 29, maybe like 28 seconds. 28 seconds every 20 milliseconds. That's 50 times 20. Oh, that's not that bad. That's like 1,000, right? Yeah, 1,000. Anyway, so in 1,000 tries, we ended up getting this. All right, great. 4 tens. Cool. I hope you enjoyed this poker project, playing around with randomness and functions a little bit. We also had some pretty nasty long if statements here, but this did make us a pretty cool code. So I'm going to ditch this guy because I don't need that anymore. Yeah, I hope you enjoy the rest of your day.